Now we are going to study the centrifugal categories of the pumps, and we'll see the principle of operation, the principal operation of dynamic pump. In dynamic pumps, energy is added to the fluid continuously through the rotary motion of the blades. This increase in energy is converted to a gain in pressure energy, which when the liquid is allowed to pass through an increased area. Now you can see it's a rotational motion of the vane impeller. This impeller transfers the rotational energy to the fluid, and when the fluid goes out from this volute, its area gets increased. So here the velocity energy gets transferred into pressure energy. And this you can see it's a semi-opened impeller. You can see one of the types of impellers. Now, pump working principle. Pump working principles. Centrifugal. It actually working on the principle of centrifugal force that you have learned in your previous studies, centrifugal force and gravity. So here is the same principle applies. This is the force that pushes the liquid away from the center in tangential direction. Now you can see if you allowing the pumps to rotate in anti-clockwise direction, and here is the volute, the liquid flows in the tangential motion, and here we can get our desired flow. Now the converting principle has converting prime mover energy into mechanical energy through the shaft, and converting mechanical energy into fluid energy in parallel, converting kinetic energy into pressure energy through the volute casing. Here I told you before, this is the volute. When the mechanical energy gets transferred into liquid, and this liquid, when it goes out of this volute, its area gets suddenly increased and the velocity goes down and the pressure energy goes up. This is how the centrifugal pumps work. Now major parts of centrifugal pump, we can see the shaft on which the impeller has been fit, which is inside the pump casing, and the shaft which is connected to the coupling, which is the coupling also connected to the another coupling side of the motor, the driving force. And shaft is protected from erosion, corrosion and wear at the seal chamber through removable sleeves. The impeller we have already discussed. The volute also already seen in the pictures. What is volute? In casing, we can read it again. Impeller are fitted inside the casing. Volute casing is curve shape, increasing cross-sectional area. Volute reduces the velocity of the liquid and increase the pressure, as we have learned before. Now we can see the major diagram, the major parts of the pump in these diagrams. That we can see these are the vanes, and this is the center point of the suction eye. We are calling it a suction eye, and this is actually the hole is called impeller or impeller blades. This is actually the volute casing. The upper part you can see, this is the volute. This outlet, when the liquid goes out of this cross section, it is called the volute. And here you can see the picture of the shaft. Okay friends, if you have any questions regarding any thing that you don't understand, you can write in the comment box and I will address that question in upcoming lecture. Here the major parts includes stuffing box. You can see the A A is here. This is the stuffing box. The B is here. B is the packing. It's actually used to keep the liquid inside the pump. The shaft sleeve, the vane, casing, eye of impeller, casing, wear ring, impeller, and discharge nozzle. This is the one of the common picture and common configuration of the centrifugal pump, which is attached to the prime mover, which is called the motor. Another picture which clearly shows, here is the wear rings. This is the wear rings. This is the gland packing. This is the lantern ring. This is the more clear picture you can see from the top side. These two, this one and this one, are the wear ring, and this one is the lantern ring, and the gland packing is here. Now we're going to study and see what radial pumps are. Different pumps have different meanings. Radial pumps, high pressure for low flow rate, centrifugal pump. Axial pumps operate on axial to lower pressures and higher flow rates than the radial pumps. And the mixed flow pumps are those who operate at higher pressure than the axial flow pumps while delivering high discharge than radial flow pumps. It's so quite clear. Now again, why centrifugal pumps need priming? There is a question, why centrifugal pump need priming? Centrifugal pump does not create suction at the start without impeller filled water, hence priming required. Priming is the process in which the impeller of a centrifugal pump will get fully submerged in liquid without any air trap or vapor trap. This is especially required when there is a first startup, but it is advisable to start the pump only after the priming. It's a good practice in industry. The priming is used to fill the water or fill the liquid in the full casing of the pump body, and we don't need any air bubble or we don't need any vapors in the casing, so to prevent our pump from cavitation. Here we can see the multi-stage centrifugal pumps. Here is an application like this. On the same shaft there are multiple, we can see multiple impellers are there and multiple volutes are there. So actually these pumps are used for high pressure and high flow rates. So it is one of the design which solve many of the industry's requirement. Here we can see the multiple vertical impeller pump or multi-stage vertical pump. Actually the vertical pumps are used normally in the condition where we need which is actually submerged in a liquid. Now we can see that is up to the centrifugal pump operations principle. Now we are going ahead to see positive displacement pumps. Here is the working principle, how the positive displacement pumps work. Positive displacement pump has an expanding cavity on the suction side of the pump and a decreased cavity on the discharge side. Liquid is allowed to flow in the pump as the cavity on the suction side expands and the liquid is forced out through as the cavity collapses. Here we can see one of the example. Here the liquid goes enter, and it's actually a screw pump. Screw, but it's positive displacement pump. And here is a single action positive displacement pump. The liquid flows from this, you can see in the picture in the bottom, and this is the, you can see the cylinder, and this is the piston. When the piston goes in outward direction, the liquid flow inside the cavity or cylinder, and when the piston goes inside, the liquid goes out. This is actually called a positive displacement pump, and it is called a stroke. When one stroke is complete from taking a liquid and moving backward the piston and again coming to out the liquid from the cylinder, this is called one stroke, one complete stroke. This is, we can see now the gear pumps. I told you this is one of the gear pumps, a positive displacement gear pumps, and this is a positive displacement single action pump. We can see from the pictures, we can clearly understand the phenomena how this gear pumps works. But you must remember that this gear pumps comes in category of the positive displacement pump. Now see reciprocating pumps. Working principle is the same that I described behind in the previous slide. This is the reservoir, this is the suction. When the liquid comes inside, this piston goes outside, and when the second stroke, you can see this piston moves inside and it discharges the fluid out of the cylinder. This is how the reciprocating positive displacement pumps work. Now we can compare both pumps. Centrifugal pumps are suitable for low head and high flow rate. Positive displacement pumps produce high head and low flow rate. Positive displacement are suitable for high viscosity application. Normally we are using this for the chemical injection purpose in the industry, and we are using the diaphragm pumps, which comes in under the category of the positive displacement pump. Centrifugal pumps are not recommended for high viscosity application because as viscosity increases, it is flow decrease. Usually a reliever is attached with the displacement pumps. Now here I end this topic, and I just going to say, if you people have any questions or any suggestion, please write in the comment box. Thank you very much for today. Meet you next time.